In this video, I'll talk about probability distributions for discrete random variables. We will learn the probabilistic properties of discrete random variables. Probability distributions are represented by tables, graphs, and formulas. Some important terminology for this section include the probability distribution, P of x. Probability distributions can be presented as tables, graphs, or formulas. The key idea is that all forms give the possible values of the random variable x and the corresponding probability of observing those values of x. Probability distribution of a discrete random variable is a graph, table, or formula that specifies the probability associated with each possible value that the random variable can assume. One example of the probability distribution is using a point representation of the probability of x. So this first illustration shows point of 0, 1, or 2, and its probability is listed here on the left. Probability of 1/4, 1/2, and so on for the scale. So we can see the point 0 has a probability of 1/4. Point 1 has a probability of 1/2, and point 2 also has a probability of 1/4. Another type of probability distribution involves the histogram, and this is just another way to use a graph to represent our probability. The histogram representation shows that values between 0 and 1 have a probability of 1/4. Values between 1 and 2 have a probability of 1/2. And finally, values between 2 and 3 would have a probability of 1/4. The third type of probability distribution involves a table. So this is called the tabular form of the probability of x. So the values of x are in the first column, and the probability of x is represented in the second column of the table. So just reading across the table, x value of 1 has the probability of 1/4, x value of 1 has a probability of 1/2, and x value of 2 has a probability of 1/4. Now these probabilities in fractional form could always be translated as decimals. So 1/4 might be shown as 0.25, 1/2 could be 0.5, and 1/4 again would be 0.25 as the decimal form of the probability. We could also talk about the probability distribution using a formula for the probability of x, such as the binomial probability distribution, and we will talk about that formula and use that formula later on in section 4.4. The requirements for the probability distribution of a discrete random variable are listed here in this table, and that is the probability needs to be greater or equal to 0 for all values of x. It is not possible to have a negative probability. So we need to make sure that when we are looking at any tables that list probabilities, or if we're calculating probabilities of x, those probabilities should be greater or equal to 0. And the second point is that the sum of the probability must equal 1. Never anything negative, never anything above 1. Because remember, probability of 1 represents 100% of your observations. So remember, where the summation of the probability of x is over all possible values of x. Let's look at a reference for classwork. In the following tables, we're going to explain why each of the following is or is not a valid probability distribution for the discrete random variable x. So we have our x values of 0, 1, 2, and 3. We have probabilities of x listed, 0.3, 0.1, 0.5, and 0.1. So recall that the probability of each individual value for x needs to be a number greater than 0 or non-negative. So all of the probabilities listed are positive numbers. And then the second criteria is that the probabilities add to 1. So 0.3 added to 0.1, added to 0.5, added to 0.1, and that total would be 4 plus 5 is 9, and 1. That is 1.0. So the summation of those probabilities does equal 1. So we could say that this would represent a valid probability distribution. In Table B, we have x values of -2, -3, 5, and 6. So it's okay if x is a negative number, but we want to make sure that none of the probabilities listed are negative numbers. So 0.2, 0.3, 0.4, and 0.1 are all positive numbers. What we're checking for is, does the sum of those probabilities equal 1? So 0.2 plus 0.3 would make 0.5, plus 0.4 makes 0.9, add 0.1, and that is 1.0. So the answer is yes. We have another valid probability distribution. In Table C, we have x values of 3, 6, and 15, and the probability of x is listed as -0.6, 1.0, and 0.2. You can see that the first probability is a negative probability, so we cannot consider this to be a valid probability distribution. And our last table, x values are -2, -1, and 0. Again, negative values for x are okay. We don't want any probabilities equal to negative values. And we have positive 0.3, positive 0.15, and positive 2. So that looks okay. The only thing left to consider is, does the sum of those probabilities equal 1? So when we add 0.3 to 0.15 to 0.2, we're going to get 0.65. That is not equal to 0.1. So this last example is not a valid probability distribution.